One part of C++ that's kind of tricky to get the hang of is understanding when to use const, mainly because const can be used in so many different ways depending on where you write it. But like with most things, using const gets easier the more practice and familiarity you have with it. So today, let's go over a few of the ways you can and can't use const. But before that, let's ask ourselves, why use const at all while we're programming? We could get away with writing the same program, which is all the same things, without ever using const. Well, the number one reason is that using const gives us safety while we're programming. Sometimes you'll know ahead of time that certain variables or data structures shouldn't be modified. When you're writing large, complex programs, or there are other people working on the same code base as you or someone else might end up modifying something you shouldn't have by accident. Well, now you've got yourself a bug in the code, and you have to track down where it came from. On the other hand, if you use const, you could catch the bug as soon as you write it. The program won't compile and will tell you exactly where and what the problem is. Catching a bug at compile time is way preferable to getting a runtime bug and then having to track down where it came from. The second reason for using const is clarity. It's really helpful when other people are reading your code, or maybe the future you is reading your code, to see a const in your code. It tells you or someone else immediately, either or both, A, the variable shouldn't be changed, or B, the variable won't be changed within the scope. That makes your code way easier to understand. Now that we have some intuition for why we use const, let's take a look at some of the different ways to actually use it. One way you can use const is when you're declaring variables. For example, const int x equals 50. And here's the basic rule of const. A const variable can't be modified after it's declared. And you must initialize a const variable at declaration time. You can't declare it first and then initialize it later. Another way to use const is with function parameters. When you put const in front of a function parameter, you're saying this function will not modify this variable. In this case, even though we're passing in num_bananas by reference to getNumMonkeys, getNumMonkeys is saying I will not modify num_bananas. Now a question. We've modified getNumMonkeys so that it calls this additional function addBananas. addBananas also takes in num_bananas by reference. Otherwise, getNumMonkeys is exactly the same, except for calling addBananas. Is this a valid program? Actually, this is not a valid program. Why? Well, because we promised that num_bananas wouldn't be modified inside getNumMonkeys. That also means that getNumMonkeys can't call another function that modifies num_bananas. So let's change the program. Now addBananas doesn't modify num_bananas anymore. All it does is print num_bananas. Is this a valid program now? Unfortunately not. This program won't compile. Even though addBananas doesn't modify num_bananas anymore, the compiler will actually require that addBananas also puts a const next to its parameter, and by doing so require that addBananas make the promise not to modify num_bananas. We've added a const in front of the parameter in addBananas. Now, is this a valid program? Actually, yes, this time we have a valid program. num_bananas is never modified, and addBananas is now also promised not to modify num_bananas, so the compiler is happy with this. All right, so what about this? addBananas and getNumMonkeys are the same as they were before, but now we can see where getNumMonkeys is being called. As we can see, we declared the integer bananas, and then we passed that into getNumMonkeys. Is it okay that we're passing in an integer, even though the getNumMonkeys parameter says const integer? Yes, this is actually okay. What the getNumMonkeys function is saying here is I will treat numBananas as if it was a const integer. But it's okay to pass in just a plain integer to getNumMonkeys. It also would have been okay to pass in a const integer to getNumMonkeys. Here's another twist. We've made one more change to the program. Now addBananas takes in a parameter numBananas by value instead of by reference, and it also modifies the numBananas parameter again. And getNumMonkeys still calls addBananas. Is this a valid program? Yes, this program is actually okay. Because addBananas takes the numBananas parameter by value, when getNumMonkeys calls addBananas, it's passing in a copy of numBananas rather than numBananas itself. So after addBananas returns, the original numBananas is unmodified and the compiler knows it too. So this is okay. Okay, one final question. We've declared a const int bananas in this main function, and then we've passed it into print bananas. Print bananas doesn't modify numBananas, so there's no prohibited modification happening, but its parameter just says int numBananas, not constant numBananas. Is this a valid program? Nope. Even though print bananas doesn't modify numBananas, the compiler is going to throw an error. The compiler needs print bananas to promise that it won't modify numBananas by putting a const in front of the parameter. Well, believe it or not, that's actually not all there is to know about const, but this is a great starting point.